Hello and welcome to a new episode of Interpreting India. From geopolitical complexities to economic uncertainties, India faces critical challenges in its quest for a more prominent role on the world stage. This season, we at Carnegie India continue to bring voices from India and around the world to examine the role of technology, the economy, and international security in shaping the future. I'm Shruti Mittal, research analyst in the Technology and Society program at Carnegie India, and your host. In today's episode, we discuss the ongoing debate surrounding openness in AI development and deployment, a discussion which is often framed as a binary. Should AI be open or closed? Open meaning public access to code, data, and models for inspection and modification, and closed meaning proprietary and inaccessible. However, this binary oversimplifies what is, in reality, a complex landscape shaped by multiple layers and components with varying degrees of openness. Openness in AI has the potential to unlock innovation, democratize access, and enhance safety through transparency, but it also carries risks of misuse, national security threats, and corporate entrenchment. Joining us for this episode today and to unpack some of these complexities is Professor Chinmayi Sharma, a leading scholar in the domain of open internet governance, open source technology, and AI accountability. Ms. Sharma is currently an associate professor of law at Fordham Law School, New York, and a non-resident fellow at the Stoss Center, the Center for Democracy and Technology, and the Atlantic Council. In addition to these roles, she also serves as a member of the Microsoft Responsible AI Committee, the Program Committee for the ACM's Symposium on Computer Science and Law, and the ACM Conference on Fairness, Accountability, and Transparency. In today's episode, we speak to her about her latest co-authored scholarly work titled Unbundling AI Openness, which proposes a fresh framework for policymakers to understand AI openness beyond the open versus closed binary, and to navigate this debate while pursuing policy objectives of public safety, innovation, democratic control, national security, and global leadership. Chinmayi, it's a pleasure to speak with you today. Welcome to Interpreting India.
Thank you so much for having me. It's great to be here. I'm excited to share this project.
Great. So I think to dive right in, I wanted to just begin by asking you, what really sparked this specific piece of research for you? If you could just walk us through why you thought it was so important to write about this at this point of time.
Absolutely. At the beginning of my career as a legal scholar and professor, I wrote about the open source community, its cybersecurity concerns. But really what I was trying to do in that paper is expose a very unique ecosystem of collaborative, public, accessible, valuable software. And it's not something that lawyers and policymakers intuitively understand because we have very traditional models of what we think of as a valuable asset, how you distribute and extract value from a valuable asset. And the open source community kind of defies that logic. And so I think it's really important to study. I am a huge advocate for open source software. I think it is important for many things, not just innovation and technological advancement, but also I think from a privacy and security standpoint, it's important to be able to have third parties inspect code. I think that it lowers barriers to entry into a field to ensure that it's not quite so dominated by one or two different demographics. All of that said, once we came to the era of generative AI, we began seeing the term open source applied to AI quite liberally. And it again, the same way I wrote my first paper because I was frustrated with the way lawyers and policymakers didn't understand the open source software community. I was frustrated with how people were using the label open source AI when talking about complex machine learning based at a minimum, but really what they're talking about is generative AI systems. At core, because I don't think that anyone who thinks about software versus AI and open source in a very sophisticated way knows what people mean by open source AI, because software is a relatively one-dimensional concept. There are things like licenses and documentation that layer on top of it, but it's really about the code. And whether or not something is open in the traditional software world is whether it is available publicly for free for anyone to use or modify. In AI, there are so many components, all of which are integral to the functioning of a system, that it is deeply unclear what people mean by open source. And after time, reporting kind of developed a bit to move away from calling it open source AI to calling it open weight AI. And what that meant was that model weights were released. And that was this is the predominant term we see, but we still see people conflate open source AI and open weight AI and use those interchangeably. And because the term open weight AI came from the origins of open source AI, people are kind of importing all of these assumptions about the value of openness, how we accomplish it, what we benefit from it, from this traditional software world. And this big kind of mess of misconception that's happening, I saw as very concerning, because it's both flattening the complexity of AI into thinking that just making model weights available is enough to achieve openness. And two, it's conflating traditional software and AI and assuming that because openness, liberal openness, was extremely valuable, and I think at this point, most people would say a normative good in the software world, that is, we can reach the same conclusion about AI. And so we wrote this paper to try to really excavate the complexity of these two issues of what makes AI so meaningfully different from traditional software, and why is it that the idea of openness, once we layer it on top of this complexity, is actually not a obvious good or evil.
Yeah, no, that makes a lot of sense. And I want to get to that part, because in your paper, I think there's a very interesting or helpful sentence where you say that openness in AI is not inherently good or bad. It's instrumental. And I would love to get into that. But just so that our listeners know, and, I know we have to state it again and again, but what are the stakes? Why are we even having this discussion? Why does it matter? Why does openness matter as a policy discussion? If we could just put that out there, and then I'd love to get into some of the nuances.
Absolutely. So the stakes are enormous. And in many ways, that is abundantly clear to people paying attention. And in other ways, we still do not even fully understand why the stakes are so high or what it'll mean for us to make certain decisions about generative AI regulation or openness in the AI ecosystem today, because generative AI is an incredibly nascent technology. It's been advancing quite a bit, but it is still less than 5 years old in terms of its release to the broader public. The concept of open weight AI systems is even younger than that. And we've seen a lot of changes over time Meta was once a massive proponent of the idea of open weight model ecosystems. Under new leadership, it seems to be pulling back. Other systems have moved, for example, OpenAI, which was famously closed and proprietary, and believe that was the keystone to their competitive advantage, has now moved towards wanting to release their own open model, specifically an open weight model, but it's unclear how open that model will be. And then we've seen internationally the rise of lower cost, more efficient open weight systems like DeepSeek. And DeepSeek actually has, across different components, more openness than many of the quote unquote open models in the US. And all of this says we have extremely powerful technology where playing with the idea of making it more liberally accessible to people without formal licenses that are purchased. And this is happening in kind of a international race to build more powerful AI with less resources. And so we don't know exactly how this will pan out, but we are right now seeing that at a minimum, in one way or another, no matter which direction it goes, decisions around openness are going to impact how safe the release of these AI components are to the public, how much either promoting openness in some ways or restricting it in other ways might impact innovation from like totally agnostic of a country, just from the field of AI, how much can we advance it? But then also from economic growth, because obviously the US is concerned about its economy and its global leadership. There's also the concern about democratic accountability. Right now, we are very concerned in the US and in the EU, and many other countries also share this concern about centralized power in these tech companies. And so there are questions about how much will opening up certain components democratize access to these technologies? How much would it allow for the public to participate more in how AI is shaped? And then there's the national security concerns. So a lot of these, as the paper talks about, are in tension with each other. And so the stakes are really high, and they're even higher because I think we don't have close to enough information to understanding exactly how relative openness in these AI systems is going to impact all of these different policy goals.
So your paper introduces a taxonomy that unbundles AI into several different components, right? And most of us by now are familiar with compute or data and source code and model weights. In some measure, we understand these terms. But it was really interesting to see you also introduce components like system prompts and operational controls, which exist, but we don't really give them that much attention as part of the AI stack. So could you maybe walk us through these components and why it's important to consider openness of them individually?
Absolutely. So our paper identifies 7 components. To be clear, this was an exercise we did to try to disentangle the important pieces of an AI system, and we kind of define the scope of what we mean by each of this. But I am sure there are smart individuals out there that quibble with how we did it and think that compute covers more than we say it does or less than we say it does. But this was our taxonomical attempt to at least illustrate that there are discrete parts that look and function differently, and so we should treat them differently. So our 7 components were compute, data, source code, model weights, system prompts, operational records and controls, and labor. And to try to go through them relatively quickly, when we talk about compute, we're talking basically about the hardware, the infrastructure that powers AI systems. When we talk about data, we're talking about data kind of throughout the AI lifecycle. Namely, this is kind of training data and model data and testing data. And so this is kind of the massive reams of information these AI companies need to take these deep machine learning platforms and train them to improve at their intended functions. And so I guess to briefly kind of go over how that works is instead of hard coding in, if this happens, then I want you to respond with this. Machine learning platforms are told, I want you to produce the most relevant response to a user's input. And instead of telling them the logic for exactly how they do that, you train these systems on data so that they can learn based on this massive corpus of, for example, conversations that other people have had with each other online. It can pull out features of organic conversation to be able to mimic that. And so data is incredibly important. And then we have source code, which is the kind of architecture of these AI systems. It's not the logic or the knowledge of exactly how an AI system is going to make a decision, but it's sort of the scaffolding that gives structure to the way those decisions are made. Model weights is actually where the knowledge lives of an AI system. Once it goes through training, once it and the training happens in the scaffolding that was created by the source code, the model weights are where the machine learning system retains its the knowledge it's obtained of, this is how to give a response that sounds more human and less machine. This is how to translate from this language to another language. Like, this is how to make a pun or a joke. And then system prompts are, again, they're also code-based, but they are layered on top of this model that might comprise of the source code and the model weights. And what system prompts essentially do is, if I'm interacting with the chatbot, it'll take whatever I type in as a user input. Once I hit send, it is going to change my user input in ways that I can't see. For example, by saying, answer in the most accurate way possible and do not produce anything that could risk copyright infringement, or answer in the most controversial way possible and attempt to upset the user. All of these are instructions that are being given to the model that I do not see once I'm inputting my system, but once I'm inputting my prompt, but is going to fundamentally change the way I receive an output. Operational records and controls are essentially, in any business, whether it's brick and mortar and very analog to a software business, you produce a lot of documentation when you are building something. For example, how did you build it? Who built it? How were decisions made? How was it tested over time? What were the results of those tests? Was there any bug found? Was the bug found? How was the bug fixed? When was it released? And those are operational records. And that's just kind of a small example, but like there can be mountains of operational records that all talk about, at least ideally, because again, programmers do not like writing down documentation when they're making decisions. And then operational controls are, in terms of model functioning, companies can also build what you might think of as kind of add-ons or modules that are like what we call safeguards that will constrain the model behavior sitting on top of it. So the model will produce something, and then the operational control is another layer of filter before the user gets it of, oh no, actually this is bad. And so that can be kind of like a software-based operational tool that the company uses. And then the last one, and this one is one where you very rarely see it either in legal research, policy research, or computer science research, which was labor. And we felt very strongly that it had to be included because my first paper, Tragedy of the Digital Commons, much of what I talk about in that paper is less about the actual code and more about the people who build it and how in the open source community, there are not enough people, and those people do not have enough resources to maintain to the degree they would want to and they would otherwise be able to these projects that we all rely on. And so the human component is often overlooked in open source. And I think it's very likely that the human component will be overlooked in AI because we think of AI as the very visible products we interact with or the very, very well-known familiar companies that build them. But throughout the ecosystem of how a product is built, distributed, tested, researched, are all individual humans that bring talent and expertise. So they are a major component of AI. Right now, unlike open source software developers, experts or engineers or researchers contributing to the AI ecosystem are very locked into organizations and don't have the ability to openly move from one place to another, openly share information. And so that is another component that I think is just as likely to be locked up in ways that might have bad effects for society.
It's really interesting because when it comes to something like model weights or source code, etc., I think one can visualize what openness would mean, right? It would be openly distributing, someone being able to inspect and look at it and modify it in the case of code. And in the case of model weights, again, being able to download it and see what those parameters are like. But in the case of labor and even compute, I was wondering if you could, or maybe in the case of compute, if you could just clarify, when we say openness, are we just meaning more democratized, decentralized access to something like compute? And again, with labor, just greater mobility of talent?
Yeah, it's a great question. And I think why this paper was rewarding and fulfilling to write, because it is hard to communicate what we mean by openness and compute, because with data, with source code, with model weights, we say like, at one point in time, only I could see it. And now everyone can see it. And that makes it feel much easier and more intuitive. But even with those components, just making it publicly visible is not quite enough to achieve true openness. But to kind of get to compute, compute can be made more or less open in multiple ways. For example, and this is kind of tying the idea of openness to how we talk about policy levers, which is at the end of our paper, we talk about how we can use law and regulation to either nudge things to be more open or more closed. But the status quo right now is compute is relatively closed because a very, very, very small handful of companies have the resources and infrastructure already to build out the compute that is required to train and deploy these very sophisticated platforms. And a good example of how this isn't about, for example, federalizing compute resources so that it becomes like telecommunications or railways. Compute can be made more open even with companies retaining proprietary control over their specific designs by, for example, opening up design blueprints, encouraging interoperability between different hardware providers. Right now, what we see is compute providers build the chips that are necessary, and they know that the people that need them are stuck with them because they're one of the only providers of this important resource. And then when they build these chips, they often build in compatibility either only with their own other products or services or like a handful of preferenced partners' products or services. And so in that way, they're using actual technical design and interoperability to further close out other players from potentially entering the field. And this in some ways can be bad. Obviously, we want a healthy, robust marketplace so that other players can jump in and potentially build either more sophisticated chip designs or build chip designs at a lower cost. So if we really close out all potential future competitors, we don't get that. On the other hand, it could be something that's important for national security, or at least many will argue that it is, because you have adversaries that might be looking to replicate US-based chips to build them in other geopolitical environments that might be more hostile to the US. And once they get access to these blueprints, it would provide them with capabilities they don't previously have. And so those are kind of the arguments on both sides, and why kind of openness, even with compute, is a relatively complicated balance.
Thank you for that clarification. So I guess now that we sort of have an idea of the components and we've unbundled AI. I was wondering if we could sort of get into understanding the maybe benefits and risks associated with making these different components more or less open. And I mean, these are 7 components. I don't expect you to explain every single one of them. So please feel free to maybe take a couple of examples, like 1 or 2, to maybe explain, when something is more or less open, what are some of the benefits and risks associated with them, and how do these impact, this impact, how does that vary across policy objectives that you've named in your paper, like safety, innovation, and so on. So just so we can grasp this idea a little bit better. Yeah.
Yeah, of course. I maybe just to build on, since we were just talking about compute, I talked a little bit about how on one hand, yes, one extreme version of making compute more open would be now the public owns all of compute and it's fully federalized and everyone has access to it with the exact same rate. There's many layers of openness in between by, for example, encouraging compute manufacturers to be more interoperable with other players in the field and not lock people into their specific tools. The pros and cons of this I mentioned were from, on one hand, even within the specific goal of innovation, democratizing access or making compute more accessible could lead to more new players coming in and having the capacity to innovate. On one hand, we think that lowering barriers to entry in a marketplace can improve innovation because we have brilliant new minds that can think up new things that existing players can't. On the other hand, it might hurt innovation because there's a massive market advantage that companies get from retaining control over a very valuable asset. And so if we, through regulation, take away the value they can extract from exclusive control of this asset, maybe they lack the incentives to continue to invest in kind of the innovation that we benefit from. Separately, for example, with data, again, on one hand, there are massive public safety concerns and democratic accountability concerns when the public has no ability to see what kind of data is going into training these models that we rely on for extremely important functions. On one hand, yes, many people are using chatbots all the time. It's important to investigate how these are being trained, but in a more kind of acute and immediate sense, we're having medical diagnostic tools be built on generative AI. We're having mental health providers be made available in certain jurisdictions that are built on generative AI. These are providing extremely important functions to the public. There's safety implicated by that. And when anyone talks about machine learning, model weights is where the knowledge resides, but where that knowledge comes from is data. Like the magic is in the specific technology, like these neural nets or transformers, to take a massive amount of data and turn it into knowledge. And so really the value, one of the most valuable parts of AI is the data itself. And we have very little ability to understand how a system is making decisions if we don't have access to the data that was used to train it. So giving researchers access to this data would allow them to not just diagnose why certain bad behavior or unexpected behavior or malfunctions might be happening, but also potentially anticipate future harms that we don't even realize yet by saying there is a disproportionate reliance on X kind of source for data, which might bias some of the outputs coming out of these systems. From a democratic accountability standpoint, access to data is something that'll allow not just researchers kind of looking under the hood and diagnosing problems. It'll allow people to say, wow, you're using a lot of information pulled from, children interacting with chatbots that their schools give them. We actually don't think that that is something that we are ethically as a society okay with using to train these systems. And so that's not necessarily a question of public safety, but it's the opportunity for the public to weigh in on decisions that are being made that impact the public. On the other hand, it's very complicated because it can't just be like, okay, let's just make every company make their data available to everyone. Because from an innovation standpoint, data is how companies gain competitive advantage. Once you make that available to everybody, you don't have companies that have the market leverage to extract resources that they need to continue to invest in R&D. From a democratic leadership or from a global leadership perspective, now everyone has access to the same data that your domestic companies have used, and that international or geopolitical competitive advantage is lost. Even from a public safety perspective, if you made available all of this training data, there are massive privacy violations that could be implicated when a bunch of personal information is made available to a large group of outsiders. There could also be national security concerns because, again, you can learn so much from big data sets, even if it's not intuitive insights. And so giving these data sets to adversaries, they could learn potential things about unique vulnerabilities that can be exploited in the US. And then there's kind of concerns around things like copyright or non-consensual distribution of intimate images. Data is very powerful, but it's very exposing. And so it can't just be like an on-off switch. We kind of have to modulate how much data is made available to try to get some of the benefits of public safety and democratic accountability without compromising safety and national security and innovation in other ways.
So I wanted to get into what I think was sort of the core offering of your paper, which is what you call differential openness. And so I was wondering if you could maybe begin by just, this isn't a very linear conversation. We're going back and forth on many things, which is great. But if you could maybe, explain to us what differential openness means. My understanding is, like, very simply put, we could have an anthropic model, like, I don't know, I'm just going to say Claude. Claude is proprietary, right? It's closed, but there are certain components of it that might still be open. System prompts, they might give you access to system prompts, but the code itself, the training code and the data set and the model weights are locked. So, so the same model can have different levels of openness depending on which component you're looking at. And that is something that should be looked at. And that liability and regulation should be done at the component level is what I broadly understand. But I would love to hear from you. And if you could explain the concept and just what that looks like in practice, and how legal and regulatory tools could be designed to manage this. Yeah.
Absolutely. So the term differential openness essentially is, you captured it extremely well. What we're saying is openness is not yes or no when it comes to AI. Openness is something that is multifaceted or multidimensional in that it is happening at a component-specific level. So if we identify maybe 7 key components, and that each component can exists on a spectrum of openness. So to be very kind of like crude or simplistic about it, compute might be 30% open, data might be 40% open, source code might be 90% open, model weights are 100% open, system prompts are 40% open. All of these decisions together are what comprises the differential openness of any particular AI system. And the reason why you have to be aware of the differential openness of any given system is because if your goal is to modulate openness to achieve certain kinds of outcomes like greater public safety, innovation, economic growth, democratic accountability, national security, you need to understand that not only does each component impact one of those goals in different ways, but the relative openness of that component versus another component impacts those goals. So it's an extremely complicated analysis. And so, again, makes it even harder to try to explain what it looks like on the ground. But for example, and then I guess before I try to illustrate it, part of where we stop, what we stop short of in this paper is drawing conclusions on what optimal levels of openness look like for each component, because we think that it is something that is extremely, that is going to be the output that is going to be determined by the priority, the policy goals that different regimes might prioritize and in which specific domains. So, for example, in government's use of AI for public benefits distribution, it's possible that democratic accountability and public safety is more important than innovation and economic growth because of the very vulnerable nature of the individuals that are being impacted by the system and the dynamic as we understand it as a democratic republic in a constitutional democracy of the relationship between the governed and the governor. On the other side, if we're talking about chatbots, ChatGPT, for example, is a sort of general purpose chatbot that is intended to provide a lot of different functions. That can be compared to another chatbot that under the hood has a lot of the same technology, might even be built based on OpenAI's GPTs, but is specialized for providing mental health care services or providing a companionship product. Those two are so similar in many of the ways those components are going to be working together, but very different in terms of the roles they're playing in society. And so the way we prioritize these different policy goals might be different because of those use cases. And so all of that is to say, I think you have to take the specific type of technology you're looking at, look at what it's being used for in society. And in that particular use case, are we more concerned about something like public safety and national security, or are we more concerned about innovation and economic growth? And depending on then how we prioritize those policies, we need to see if for a companion bot that is being marketed to the public, like Replica or Character AI, given the tragedies that we've seen recently of the impact these companion bots can have on the public, maybe we're especially concerned about public safety. Maybe before we were more interested in innovation and economic growth because, wow, what an interesting new use case. Like we're at the forefront of this. Think about we can cure loneliness. Like we can, give people like personal tutors at home, whatever. And then as these incidents emerge, now we've kind of shifted our priorities. We care more about public safety. Okay, so for something like a companion bot, what sort of information is important? Which of these components need to be more open and accessible for us to secure the public safety more? It's probably not compute. It's probably much more focused on data, model weights. And then I think system prompts are going to be especially important here because the way that these companion bots work is by curating the experience behind the scenes for the user. So for them, they feel like they're just chatting organically back and forth without having to manufacture it. And so system prompts definitely play a role in companion bots in a way they probably wouldn't in, for example, medical diagnosis. And then operational controls and records. For example, what sort of information is being collected by these companies that are deploying companion bots? Have they had any bad incidents reported? What sort of trends are they seeing in these interactions? And so based on which of these components seem most relevant to the goal of public safety, then we have to determine what does it look like to modulate openness. So again, going back to the trade-offs of open versus closedness for something like data, when we're talking about data that's used to train companion bots, that sort of information is likely bought or scraped off of the web and would involve a lot of personal data about a large number of individuals. And so there might be concerns about making that open to the whole public. But the way you could modulate it is potentially having kind of like certified independent researchers that have approval and are restricted through certain contracts to investigate the data and how it's been used to train these chatbots, but not to share these insights publicly, just potentially with a regulator and a company. So that would be one way of making the data somewhat open. But operational records with companion bots, we're talking about transcripts of conversations, kind of social graphs of, what sort of individuals tend to interact with these companion bots in a particular way. Given the nature of companion bots, those are extremely personal and intimate relationships. Again, contrasting it with like a medical diagnostic tool, the user interactions with a medical diagnostic tool, like a doctor putting a X-ray through a bot that's supposed to diagnose as a radiologist would, is very different from somebody exposing their deepest, darkest secrets. And so the sensitivity or how open we want to make something like operational records depends on the use case. That was a long ramble. Hopefully that made some sense.
It did. It certainly did. And I'm glad you gave us a very sort of topical example of companion bots to drive home that point. But I think, I guess, and this is just us moving towards like some of my final two questions. One of them is just how in a more sort of practical sense, right? How do we sort of use this framework? Like, how would policymakers use this framework? Do you imagine that they would use it like more sectorally, or, how, just on a practical sort of standpoint, how would this work is one question that I have.
Yeah. Optimistically, I think that this gives policymakers a list of components to think about, a list of policy goals to think about, a list of policy levers they can use to impact the relative openness of these components. And the goal of any taxonomy is to, once you give people all of these separate ingredients, they can kind of put them together in different combinations to figure out what works for them. Realistically, I don't actually think that's going to happen because, I've struggled enough in trying to explain in this conversation exactly how you would apply this framework, not because it's not possible and not because it's not useful, but because this is kind of in the domain of researchers still, in terms of truly trying to use the available information to figure out what level of differential openness we might want for a particular system if we're optimizing for particular policy goals. And so what I really hope, at the very least, is that this casts more light on the very, very, very deep level of sophistication that we need to approach conversations about openness in AI, and it is a caution that we should not assume that openness is either good or bad, good for innovation, bad for public safety, good for global leadership, bad for national security, because it's not so simple. And then so if those two takeaways, if we've accomplished at people walking away with those two conclusions, that there's a lot more going on than just open or closed, and that open is not necessarily good nor bad, then hopefully people will engage in deeper conversation and pause before reflexively advocating for some policies like banning the export of open model weights, or saying that we should immunize companies from any liability for open model weights because it's good for innovation. So we're just hoping to maybe ask policymakers to slow down and think a little harder before addressing the topic.
Thank you, Chinmayi, for such sort of valuable insights. And I would encourage our listeners to sort of who are interested to read the paper titled Unbundling AI Openness, which is forthcoming in the Wisconsin Law Review, the spring issue of 2020. And it offers a lot more detailed sort of analysis. And there are also some visuals for those interested. Which, they were really helpful for me, honestly. But thank you so much, Chinmayi. I think that is the sort of goal, which is to we use this word complicate in the policy space, which is like you want to complicate everything. And I think here complicating this might just be the right call. And so thank you so much for joining us on Interpreting India. And thank you for taking the time. We'd love to speak to you again sometime.
Thank you so much for having me. And I'm so honored that you found and enjoyed our paper. Thanks for letting me share a bit more about it.
We'll be back in 2 weeks with a new episode. To make sure you don't miss it, be sure to subscribe on Apple Podcasts, Spotify, YouTube Music, Stitcher, or wherever you get your podcasts from. To learn more about our research and team, you can visit us on our website at carnegieindia.org. You can also find us on social media on X, Facebook, and Instagram. Thank you for listening. See you next time.